All right, here we go. Algebra 2, Unit 1, Lesson 3. We're going to work on solving linear equations. All right, so again, an equation is a statement that two expressions are equal. A linear equation has one variable, and it can be written in the form, so again, linear equation. Linear kind of means like a straight line. We can write it as ax plus b equals 0, where a and b are constants, which just means numbers. And also a cannot equal 0, because otherwise we would not have a slope. So again, this is kind of going to be a review from Algebra 1, but let's talk about solving an equation with a variable on one side. So for example, 4/5 x plus 8 equals 20. My first step is to separate the left side from the right side. And I like to talk about it as when you solve equations, you're trying to undo them. So we're going to use our order of operations, which is PEMDAS, but we're going to work backwards. So we're going to start with subtraction and addition first, and then division, multiplication, exponents, and then parentheses. So I see that, hey, I have an adding 8, a plus 8 here. So my first thing I'm going to do is subtract 8. So this cancels out. However, in an equation, anything I do on the left, I also have to do on the right. So what I'm left with is 4/5 x equals 20 minus 8 is 12. And now this fraction, okay, this is 4/5. So if I want to think about it as 4/5 multiplied by x, to undo multiplication, I have to divide by 4/5. However, remember, when we divide fractions, we actually multiply by the reciprocal. So what that means is I'm going to take my initial 4/5 x and I'm going to multiply it by the reciprocal, which is 5/4. I flip the numerator and the denominator. So if we look right here, let's get rid of this x for a second. 5 times 4 equals 20, and 4 times 5 equals 20. So 20 divided by 20 cancels itself out. We can also look at it as, hey, I have 4 divided by 4 here. I have 5 divided by 5 here. So it's going to cancel out. So if I jump back into my equation, I have 4/5 x equals 12. What I need to do is multiply by 5/4 on the left, and I also need to multiply by 5/4 on the right. So again, the left side cancels out, which is exactly what we wanted. We're left with x. 12 times 5 is 60, and 1 times 4 is 4. 60 divided by 4 is 15. So my answer is x equals 15. You can always, always, always take this number and plug it back into your original equation. So I'm going to look at 4/5 times 15 plus 8 equals 20. Again, 4/5 times 15 over 1, that's 60 over 5, 60 over 5, plus 8. 60 divided by 5 is 12. So 12 plus 8 equals 20, and that is a true statement. So we know we did it correctly. Again, that's checking your work. I always check your work, okay? I recommend doing it. It is not necessary. It's not required. But again, if you made a silly mistake, you can definitely find your mistake that way. All right, so let's take a look at a kind of verbal model, okay? So during one shift, a waiter earns wages of $30 and gets an additional 15 15% in tips. So again, $30, 15% tips. The waiter earns $105 total. What is the total of the consumer's food bill? Okay. So $105 total. So we're going to kind of, again, use words first. So the total income equals wages plus percent of tips. And then it's got to be multiplied by the food bill. So altogether, the waiter earned $105. They got $30 in their salary or their wages. And then they earned 15%. So remember, percents are out of 100. So 15 out of 100 is 0.15. So I'm going to say 0.15. And then I don't know how much the food bills were. So we're going to use a variable, okay? Variables are unknowns. So if we don't know something, we can use a variable. Now, if I separate my left and my right side and I do PEMDAS backwards, PEMDAS, okay? I'm going to start with all my addition and subtraction. So I see I have a positive 30. So if I take 30 from the right side, I need to take 30 from the left side. And 105 minus 30 is 75. And I'm still left with 0.15x. This is 0.15 multiplied by x. So again, what's the opposite of multiplication? How do you undo multiplication? Well, you have to divide. So I'm going to divide both sides by 0.15. And 75 divided by 0.15 is going to be 500. So the total food bill was $500. Another example, okay, again, sometimes you have variables on both sides. So let's say we have 7p plus 13 equals 9p minus 5. So what I'm going to do is I need to get all of my p's together, and I also need to get all of my constants together. Okay, so again, I got to start collecting things that are similar or like terms. So I like to deal with my variables as being positive. So I'm going to subtract 7 on both sides. So I'll, again, do one step at a time. 13, this cancels out, equals 9 minus 7 is 2p, subtract 5. And again, I got to get p by itself. That's my overall goal. So if I got to get p by itself, well, I better get rid of this subtract 5. And the only way to get rid of subtract 5 is to add 5. 18 equals 2p, divide by 2, divide by 2, and I get 9 equals p. Again, you could check your work if you were unsure. Plugging in, every time you saw a p, you would plug in a 9. We can also solve problems using the distributive property. So for example, 3 parentheses 5x minus 8 equals negative 2 parentheses negative x plus 7 subtract 12x. Now, we got to simplify things first before we start combining stuff. So I would recommend, again, because we have an x here and no x here, we can't simplify. Same deal here. I don't know what x is, so I can't simplify anything in my parentheses yet. However, I can take 3 and multiply it into both terms, and I can take negative 2 and multiply it into both terms. So let's go ahead and do that. 3 times 5 is 15, and I have to bring along the x. 3 times negative 8 is negative 24. Negative 2 times negative x, a negative times a negative is a positive. Negative 2 times 7 is negative 14. And don't forget to bring down negative 12x. So now I'm looking for like terms. And again, I want to stick on the same side of the equal sign first. And I see I do have some like terms. So I'm actually going to combine these two. I'm going to keep everything the same on the left. Again, do one step at a time. Don't do too much. Positive 2 take away 12 is going to give me negative 10x. And I haven't done anything with the 14 yet. Now, do we have all of our x's together? We have them. We've simplified on the left side and on the right side, but we have x's on both sides. So again, Mr. Larson likes to deal with positive variables. So I'm going to take this negative 10x and I'm going to add it. The opposite of negative 10 or negative 10x is to add 10. So I'm going to add 10x on both sides and get 25x subtract 24 equals negative 14. Now, my goal is to get x by itself. So if I want to get x by itself, I got to get rid of this negative 24. So I'm going to add 24 on both sides. 25x equals negative 14 plus 24. Okay, I'm going to add 24, and that's going to leave me with 10. Now, the only thing that I have to finish this problem is do 25 times x. What's the opposite of 25 multiplied by x? To undo that, you must divide. Therefore, x equals 2.5. Oh, Mr. Larson, you made a oopsies. It's not 2.5 because 10 is smaller than 25. So we can keep it in fraction form. That's fine. What does 10 and 25 have in common? Oh, they both have a 5 in common. So I'm going to simplify by dividing by 5 and dividing by 5. And I'm going to get 2/5. So it's actually 2/5, or if you wanted it as a decimal, it would be 0.4, okay? Again, either answer would work. I will specify how I want your answer written. But again, for right now, either one works. It's good practice to deal with fractions and decimals. Okay, let's see here. Last example. If you take 8 minutes to wash a car and it takes a friend 6 minutes to wash a car, how long does it take the two of you to wash 7 cars if you work together? So again, the first thing we got to do is kind of write a verbal model or get it out in words. So let's look at our rate. So let's do our rate. And I'm going to multiply that by time, which again, time in this case is minutes, plus our friend's rate, which again is cars per minute. And then he also has time in minutes, is going to equal, I'm running out of room, cars washed. So again, I know it's tricky with words. So it's kind of easier, I think, with numbers. So if I can wash 1 car in 8 minutes, I don't know how many minutes I'm going to work. So I'm going to use T for time because I don't know. And my friend can wash 1 car in 6 minutes. I don't know how much time he's going to work. That's what we're trying to figure out. So we're going to use T because we don't know what it is. But we know that the total cars washed is 7. 7 cars. So we're going to kind of start plugging in some stuff. So again, let's go ahead and turn this into a fraction. So I have 1 car in 8 minutes. So that's 1/8 times however many minutes I work. Plus, my friend, who's a little bit faster than me, works 1 car every 6 minutes. So again, there's my fraction. but I know it's going to equal 7. Now, the problem we have is we can't add fractions if we have different denominators. So side work, okay? Let's see here, sidebar. I'm gonna count by 8 and figure out what is my least common denominator. 8, 16, 24, 32, 40. I might have to go further, let's see. 6, 12, 18, 24, 30. And I found, hey, I do have something in common. I have a 24 and a 24. So we need to turn these, we need to multiply this so that we can get common numbers that we can combine. So I'm going to multiply 8 times 3, and anything I do on the bottom, I have to do on the top. And I'm going to multiply this one by 4. Again, anything I do on the bottom, I have to do on the top. So I'm going to get 3 over 24t plus 4 over 24t equals 7. 3 plus 4 is 7 over 24t equals 7. And now I got to think about, how do I get t by itself? This problem is saying 7 divided by 24, so 7 24ths multiplied by t. We talked about it earlier. To undo this, I would have to divide by 7 24ths, but when we divide fractions, we multiply by the reciprocal. So I'm going to multiply by 24 over 7, and if I do that on the left side, I should also do that on the right side. 7 divided by 1 is 7, so I'm not changing the problem at all. Let's see here. 24 divided by 24 cancels out. 7 divided by 7 cancels out. I'm left with t. And it's actually pretty nice because if I look right here, I have a 7 divided by 7. So all I'm left with is 24 over 1, which 24 divided by 1 equals 24. So to answer the initial problem, we can wash 7 cars between me and my friend in 24 minutes.